Hello everyone, I Professor Bhavik Kumar M. Kataria welcomes you into the video series of computer networks. We are discussing unit number 3, transport layer. In this unit, till today, we have discussed transport layer services, multiplexing and demultiplexing, connection-less transport UDP, and connection-oriented transport TCP. Today, we are going to discuss principles of reliable data transfer, and then after in next session we will discuss congestion control and TCP congestion control. So let's see what we have discussed till today. So basically, transport layer is responsible for the process to process communication. It means how one process is executing in any system is going to communicate with the another process which is executing on another system. So that is the responsibility of transport layer from process to process communication. Up to the end device, network layer is working. If someone asks to you what is the responsibility of network layer, so network layer is producing the connectivity from one device to another device, whereas transport layer producing the connectivity from one process to another process. Now, if we will look about the transport layer services, so service point addressing, segmentation and reassembly, connection control, flow control, and error control. This thing we have already discussed in detail. Then after we have discussed the multiplexing. There were 4 types of multiplexing. In terms of analog multiplexing, there is 2 types. First one is frequency division multiplexing, and second one is wavelength division multiplexing. Whereas in digital communication, there is again 2 more types, that is TDM, time division multiplexing, and ATM, asynchronous time division multiplexing. We have discussed the user datagram protocol, UDP, for the connection-less services, as well as we have discussed TCP, transmission control protocol, for the connection-oriented services. Today, we are going to discuss the reliable data transfer and sliding window protocol. So, let's start today's session. What are the principles of reliable data transfer? So, first, we will discuss building a protocol for the reliable data transfer. So, to building a reliable data transfer protocol, we will start with the stop and wait protocol first. We will start with the stop and wait protocol. And then after, we will discuss pipeline reliable data transfer protocol. In this case, we will discuss sliding window protocol. Sliding window protocol. There were 2 types of sliding window protocol. First one is go back and second one is selective repeat. So we will discuss all this thing in detail in 2 sessions. Today we will discuss up to the sliding window protocol, and in next session we will discuss go back and selective repeat. So before today, we have discussed the efficiency of stop and wait protocol in our lecture number 4. If you will refer the our lecture number 4, so at that time we have discussed the delay in packet switching. So if you are still remain to watch our earlier videos like services of transport layer, so you can click on I button at top right corner and you can watch the video of services of transport layer, as well as if you want to watch the lecture number 4 about the delay, so you can go at a playlist and you can search the video session 4 for understanding the fundamentals of delay. So here we will use the types of delay and fundamentals of delay. So hope you understand the earlier session of delay. Now let's see. First, we are going to determine the capacity of channel, link or a wire. Questions should be asked into the examination with the capacity of channel, or they can ask like the capacity or link or a capacity of wire. So let's see one by one. Suppose it is our channel, get it, and we are transmitting 1 bit per second. It is channel bandwidth. Now first understand what do you mean by the bandwidth. Like someone asked to you bandwidth. Get it? Many times you are listening the words bandwidth is 5 Mbps or bandwidth is 2 Mbps, bandwidth is 10 Mbps. So let's first understand what is the meaning of bandwidth. Get it? So let's see here. Bandwidth is 1 bit per second. So it means per second we are able to transmit 1 bit. Get it? We are transmitting 1 bit per second. So suppose that is our first second. So what happen into the next second? That bit will move forward to the next, and new bit will arrive here. Get it? So as a second time or second moment, we are transmitting second bit. What happen again next? So that bit will move forward again next, and third bit will arrive. So at a third second we are transmitting third bit. At a fourth second we are transmitting fourth bit. At a fifth second we are transmitting fifth bit. Get it? Suppose we have a time of 10 seconds. So within a 10 second we are able to send 10 bits. Get it? That is the meaning of bandwidth. Now here this time duration we will consider as a propagation time. Get it? So there is a little bit variation between transmission time and propagation time we have discussed during the delay. Suppose it is our sender S, and here it is our receiver R. Get it? And that is the channel between sender to receiver. So whatever the packets, suppose it is our data packets, we are transmitting into the channel. So this time is known as a transmission delay. It is known as a transmission delay. Whereas when data packets will travel from sending side to receiving side, packet will reach at here. So this amount of time is known as a propagation time or a propagation delay. So hope you are clearly understanding the difference between transmission delay and propagation delay. Whenever sender is transmitting data on channel, like we have discussed during the multiplexing, before the multiplexing there is a requirement of modulation. After doing the modulations we are doing multiplex, and then after data will go inside the channel. So whatever the process required during the sending side, this process will require some amount of time, and this time is known as a transmission time or a transmission delay. Whereas data packet will travel from sending side to receiving side, this time is known as a propagation time or a propagation delay. So suppose propagation delay is 10 seconds, so we are able to send 10 bit per second because our bandwidth is 1 bit per second. So at a second we are able to send 1 bit. So if we have a 10-second propagation time, so within a 10 second we are able to send 10 bits. Get it? So that is the bandwidth of channel. Now let's understand. We are discussing with respect to stop and wait protocol. So what's happened in case of stop and wait protocol? Actually, suppose like bandwidth is a 1 Mbps. So in place of 1 bit, here we are sending the 1 megabit per second. Get it? Mega means there is a multiplication of what happens in terms of kilo. There is a multiplication of 1000. Again there is a multiplication of 1000 into 1000. So it is 10 raised to 3 and 10 raised to 6. Get it? So here we are sending 1 Mbps data. Get it? But in terms of data, you have to consider kilo means 1024. In terms of data, you have to consider kilo means 1024 whenever there is a size of data. Get it? And otherwise for the remaining thing you have to consider kilo as a 1000. Get it? Whenever look like there is a in terms of bandwidth. Get it? So kilo means 1000, it means 10 raised to 3, whereas in terms of length of data, get it, size of data, so at that time you have to consider 1024. So that is the variation, keep in mind always. Now suppose at a time per second we are able to send 1 MB data, it means bandwidth of channel is 1 Mbps. Every second we are transmitting new 1 MB data. Get it? Like first second we are transmitting 1 MB data. So at a second time or a next second 1 MB data will move forward and new 1 MB data will arrive. What happened at first second? First 1 MB data will move forward, second 1 MB data will move forward, and third 1 MB data will arrive. So every second new 1 MB data we are able to transmit from this channel. So that is the 1 Mbps channel. Now look about the stop and wait protocol. So what's happened in terms of stop and wait protocol? So we are using transmission time only. Suppose here we are sending the data. Get it? We are sending one data packet from here. Get it? So it is our transmission time. Get it? So then after data packet will travel towards the destination, and again receiver will send acknowledgement of that signal. So in this duration we are not sending the data, we are waiting for the acknowledgement. When we are sending next, we will send from this time. Get it? So this amount time is a propagation time. Get it? So at a time if we will look about the how many data we are able to send, so efficiency of stop and wait protocol is equal to 1 upon 1 plus 2a. That is we have already derived in our lecture number 4, 1 upon 1 plus 2a. Get it? So if we will put equation 1 upon 1 plus 2a, so a is a propagation delay upon transmission delay. Get it? Propagation delay upon transmission delay. Now in terms of transmission delay is equal to L by B. Equation of transmission delay is equal to L by B. Get it? So whenever you will put the L by B here in terms of transmission delay, so you will get 1 plus 2 into delay of propagation multiplied by B divided by L. Now if you will took this equation, 2 into delay of propagation into bandwidth. Get it? So that is the total channel capacity. Why? Let's see. Suppose you are finding the area of any space. So what you are considering L by B. Suppose you are going to find the area of this rectangle. So you will consider width B and length L. Get it? So you will multiply by L by B for finding the area. Or if there is a square, so you will put L square, L multiplied by L. Get it? Right now, if we want to find out the capacity of channel, so what we will do, bandwidth into propagation delay. Get it? Because total time is 10 milliseconds. At a time we are able to put 1 bit. Total time is 10 seconds propagation time. And capacity of channel is 1 bit per second. So that is our width, that is our length. Get it? So our capacity will be bandwidth into delay of propagation. We will multiply bandwidth with the delay of propagation. So that is our channel capacity, bandwidth into delay of propagation. But here we are considering from the single side, from the sending side. It means right now we are looking for the half duplex only. Suppose channel will full duplex, then what's happened? Capacity become twice. So that's why we are taking 2 multiplied by bandwidth of delay of propagation. So suppose channel is full duplex. So capacity becomes double. For the half duplex, it is bandwidth into delay of propagation, and for the full duplex, it is 2 into bandwidth into delay of propagation. Get it? Now, if we will look about the efficiency of stop and wait protocol. So, let's see here, you are getting this equation 2 into delay of propagation into bandwidth, which is actually capacity of channel. This equation is actually a capacity of channel. So now, if you will look about the stop and wait protocol, efficiency of stop and wait protocol. So 1 upon 1 plus 2. So this equation is arrived into the 1 upon 2 into delay of propagation multiplied by B divided by L. Get it? So whenever there is a thick pipe, so efficiency will be decreased. Whenever there is a thick pipe, so efficiency will be decreased in case of stop and wait protocol. Whereas when there is a thin pipe, so efficiency will be increased. How can we say that? Because here this time we are wasting whatever the total capacity is there. Out of this capacity, many of the times we are wasting into the propagation delay. We are transmitting only at a transmission time. Get it? Like for the first second we are transmitting. Get it? And remaining seconds, whenever data is into the path, so data is traveling from sender to receiver and acknowledgement is traveling from receiver to sender. So this time is a waiting time. Get it? So this entire time is going to be wasted into the stop and wait protocol, because we have to stop till the acknowledgement arrives. Get it? After sending the data, we will stop. Why the name is stop and wait? After transmitting the packet, we will stop and wait. How much time we will wait? Till the acknowledgement arrives. Whenever acknowledgement will arrive, then and then we will send the next packet. So that's why there is a name of protocol is stop and wait. So there is if channel capacity is greater, so again it is meaningless, because we are going to stop after transmitting the one data packet. Whenever acknowledgement will arrive, then and then we will send the next data packet. So that's why whenever channel capacity is high, it means thick pipe. So it is useless for the stop and wait protocol. Then stop and wait protocol will work better whenever there is a thin pipe. It means stop and wait protocol will work effectively whenever channel capacity is less. Get it? Let's see next about the fundamentals of pipelining. Here you will be able to understand this parameter perfectly about the thick and thin pipe. Now, at a transmission time, we are sending a one packet. That is our transmission time. Whatever it should be, 1 second, 2 second, 5 second. That is our transmission time. It means we are sending one packet only. In terms of stop and wait protocol, at a transmission time, we are sending only one packet. So how many packets we are able to send into the 1 second? Get it? So at a 1 second, we are able to transmit 1 upon delay of transmission packet. That is nothing else but triangle. 1 multiplied by 1 divided by delay of transmission. I put triangle here, nothing else to solve out the equation. If as a transmission time we are able to send one packet, so at a 1 second we are able to send 1 upon delay of transmission packets. Get it? Now at a 1 second we are able to send 1 upon delay of transmission packet. So what is the total capacity? Total capacity is 2 into bandwidth into delay of propagation. That is the total capacity of full duplex channel. So during this capacity, get it? Total capacity. It means first there is a transmission time, and remaining time we are waiting into the propagation. Get it? First propagation time for the sending side and second propagation time for the receiving of acknowledgement. So that's why we are taking 2 into delay of propagation. So total time, in terms of total nodal delay, we are considering, if you remind the equation of delay, so total nodal delay is equal to transmission delay plus propagation delay plus queuing delay plus processing delay. So queuing delay and processing delay are negligible. We are considering transmission delay and propagation delay only. But propagation delay we are considering 2 times. One is for the transmission of data and second one is for the receiving the acknowledgement. So total time is equal to transmission time plus 2 into propagation time. So as per we have derived here, at a 1 second we are able to send 1 upon transmission time packet. So if we are able to send we are sending at a 1 second 1 upon delay of transmission packets or a 1 upon transmission time packets. So at a total time, how many packets we are able to send? So again, put the triangle to solve out this equation. Delay of transmission plus 2 into delay of propagation multiply by 1 upon delay of transmission divided by 1. So if you will put this equation, if you will go to the sort out, so you will get delay of transmission plus 2 into delay of propagation divided by delay of transmission. Get it? It will arrive into the lower side. Now, what is exactly this equation is saying? If you will look this equation, get it? So let's see here again. It means 1 plus 2a. It means 1 plus 2a. Get it? Let's see 1 upon 1 plus 2a. It is 1 plus 2 into delay of propagation multiplied by b divided by l. Get it? And if you will look here, delay of transmission plus 2 into delay of propagation divided by delay of transmission. Now, delay of transmission remove. So you will get 2 into delay of propagation. Get it? Now 2 into delay of propagation, it means 1 plus 2a. Get it? So at a total time we are able to send 1 plus 2a packets during this total time. During this entire time we are able to send 1 plus 2a packets. But how many packets we are sending here? We are sending 1 packet only. We are sending this 1 packet only out of 1 upon 1 plus 2a. We are sending 1 packet. How many packets we are able to send? We are able to send 1 plus 2a packets, but actually we are sending 1 packet. That's why the efficiency of stop and wait protocol is 1 upon 1 plus 2a. Are you able to understand now why the equation of efficiency of stop and wait protocol arrived 1 upon 1 plus 2a? Get it? Because at a time, during this total time, we are able to send 1 plus 2a packets. But at a time, we are sending 1 packet only. Capacity is 1 plus 2a, but we are sending 1 packet. So that's why efficiency is 1 upon 1 plus 2a. Now, let's see. If you are understand this thing very well, efficiency is equal to 1 plus 2a. Get it? Because at a time when we are able to send 1 plus 2a packets, every second we are sending the packets without stopping. During the stop and wait protocol, after sending 1 packets, we are going to stop and wait. Whenever acknowledgement arrives, then and then we are sending new packets. But suppose you are keep sending without going to be stopped, so you will be able to send 1 plus 2a packets. That is total capacity. Now let's see one example. Transmission time is 1 millisecond and propagation time is 1.5 millisecond. Now let's see, if transmission time is 1 millisecond and propagation time is equal to 1.5 millisecond. So that is our transmission time, 1 millisecond. To transmit the data packets into the channel, we will require 1 millisecond. Whereas for the traveling, we will require 1.5 millisecond. So what is the meaning? 1.5 millisecond we will require for the sending side up to this point. Up to this point it is 1.5 for the sending the data. To reach from sending side to destination side for the data packets. Again, whenever receiver will send acknowledgement, so again it will reach after 1.5 millisecond. It will reach after 1.5 millisecond. Get it? So if we will put the equation here, efficiency is equal to 1 upon 1 plus 2a. So 1 upon 1 plus 2a. A means, what is the meaning of A? A is a propagation time upon transmission time. Delay of propagation upon delay of transmission is equal to A. So in place of A, we are putting delay of propagation upon delay of transmission. Why? Because here, get it? In terms of 1 plus 2A, whenever we have derived the equation, so at that time, we have taken A in place of delay of propagation upon delay of transmission. We are writing A. So that's why in place of A, we are putting delay of propagation upon delay of transmission. Delay of propagation is equal to given into the data 1.5. So in place of A, we are putting 1.5 upon 1. Transmission delay is 1. Get it? So whenever we will solve out this equation, 2 into 1.5. So what we will get? 2 into 1.5, we will get 3. 1 upon 1 plus 3 by 1. So what is the answer of 3 by 1? Answer of 3 by 1 is 3. So we will get 1 upon 1 plus 3. So finally 1 plus 3 is equal to 4. So we will get 1 upon 4. Efficiency of 1 upon 4. It means 25% efficiency is here. Efficiency is 25%. Out of 4 seconds, we are able to send 1 packet only. Now, if you want to if you don't want to go with the calculations, like suppose question asked to you into the competitive exam. So what you have to do? There is no need to put equation and making the calculations, because you have a very little amount of time during the competitive exams whenever you are going to solve the MCQs. So go with the diagram. What is the transmission time? Transmission time is 1 millisecond. What is the propagation time? Propagation time is 1.5 milliseconds. So 1.5 millisecond is required for the transmission. 1.5 millisecond another required for the acknowledgement. So 1.5 plus 1.5 total 3. 1.5 plus 1.5 total time is 3 milliseconds. Plus here 1 millisecond for the propagation. So 1 and 3, 1 plus 3, total 4 millisecond is here. Out of 4 millisecond, how many packets we are able to send? We are able to send 1 packet only. So out of 4 seconds, we are able to send 1 packet only. So it means we are sending 1 packet out of 4 seconds. As per look like we have derived the equation of stop and efficiency of stop and wait protocol. Total capacity was 1 plus 2a. But we are able to send 1 packets only. So that's why efficiency is equal to 1 upon 1 plus 2a. So same here. Total time is 4 millisecond. Out of 4 millisecond, we are using 1 millisecond only. Out of 4 millisecond, we are using 1 millisecond only. Remaining 3 millisecond, we are wasting for the waiting time. Get it? So that's why efficiency is equal to 1 upon 1 upon 4. So no need to go with the calculations. If you are going to solve out the MCQs, you can easily solve out with the logical fundamentals. That is RTT 2 into delay of propagation. It means total time. Sending time and receiving of acknowledgement time. One first propagation time for the sending of data, and second propagation time was the receiving of acknowledgement. So round trip time is equal to 2 into delay of propagation. Somewhere data given with the RTT, like transmission time is 1 millisecond, and round trip time RTT is equal to 3 milliseconds. RTT is equal to 3 milliseconds. 3 millisecond means total time for the data and acknowledgement. So whenever you will divide by 2, so you will get propagation time. Get it? RTT time is equal to 2 into delay of propagation time. So whatever given to you into the data, like they can give you the propagation time, or they can give the RTT time. Whatever time is given to you, you can find out the efficiency of stop and wait protocol. So that is the fundamental of pipelining. So in our next session, we will discuss the sliding window protocol. In our next session, we will discuss sliding window. So if you have any query regarding to the capacity of channel and pipelining, you can make your comments on comment box. I will try my best to solve out your all queries. So hope you are understanding very well.